Um, please, if you registered following Nuri Martinez's registration link, your name is appearing as Nuri Martinez. So if you could go to your participants button and change your name to yourself, that would be great. There are quite a few Nuri Martinez's on the screen right now. Okay, so with that, it's a pleasure to introduce my CUNY colleague, Dr. Nevin Cohen, who is an associate professor at the CUNY School of Public Health and is the research director for the CUNY Urban Food Policy Institute. So Nevin has an extensive history in researching shopping patterns, nutrition programs such as SNAP, and he's presently continuing this line of investigation with research on the impact of the pandemic on shopping and nutrition in New York City. In parallel with this work, Nevin has studied urban agriculture, including a recently concluded 3-year project tracking urban farming sites at 6 New York Housing Authority locations. His book, Beyond the Kale, Urban Agriculture and Social Justice Activism in New York City, is, so far as I know, the only book-length study of New York City urban gardens and urban farming. And in it, he emphasizes the need to address structural inequalities in the food system and how people working in that area are addressing deeper inequalities. Nevin will talk to us today about the 5-country urban agriculture study in which he is engaged for the Belmont International Forum. Nevin? You're muted, still muted, Nevin.
You would think I would have it down by now. Thank you, Michael and Cecilia and the rest of the network for inviting me here today. It's really a pleasure to talk about the work that I'm involved in, and it's always fun to talk about urban agriculture because I've been working in that field for so many years. What I'd like to do today is speak for about 30 minutes to tell you about a project that has been underway for 2 years and is going to be completed in the coming year. And I'm always hesitant to talk about projects that are still underway and not completed, but I'd like to actually get your feedback and thoughts on the project, even though some of our research products are not complete yet and won't be complete for several more months. But I'll give you an overview of the project, and let's start right now. And I will hang on a second. Share my screen. Sorry about the little technical glitches, but they should resolve themselves. Okay. Okay, so the project is called the Food Energy Water Meter, and I'll explain what that means. And you can see the network of funders at the bottom of the page. My research and the research of my colleagues at the University of Michigan were funded by the National Science Foundation. I'll give you a little bit about the project background, and the project background starts in Brownsville at Howard Houses. This is a photograph of one of the farms at NYCHA projects that Michael mentioned, predated the NSF research. For 3 years, I was evaluating a project at 6 NYCHA developments in which residents who were stipended by the AmeriCorps program and led by an organization, Green City Force, learned to build and operate farms, fairly large-scale farms at 6 NYCHA developments. And they were designed to do a number of different things. You probably realize that urban agriculture is not about the food. It's really about all of the co-benefits that result from farming in the city. And those include activating the spaces in NYCHA developments, in supporting community cohesion, in helping to support better nutrition among the residents. And for Green City Force, this is really a workforce development job training program for the youth who all live in NYCHA developments and are spending a year learning various skills that aim to help them get jobs after they finish the program or go on to college. And my 3-year evaluation found that this is a really successful program, doing everything from diverting stormwater by greening these spaces to resulting in the core members, the young people, really moving on into careers or school. The Few Meter project uses the farms at NYCHA as one of the case studies, and it has a number of different goals. So the farms at NYCHA evaluation was really evaluating the program outputs and outcomes. The Few Meter project is also an evaluation project, but a little bit different. One goal is to develop a system to analyze urban agriculture from a Nexus perspective. Our goal in the project is to actually develop a tool called the Few Meter to allow urban farmers to improve the efficiency of their operations. We aim to measure the production efficiency of different types of urban agriculture, and I'll explain that when I show you the different projects. We also are modeling the material flows, energy, water, labor, and other resources using life cycle assessment and urban metabolism methods. We're measuring the social benefits of urban agriculture by surveying the participants in these projects and analyzing that. We're looking at the policy context in each of the study cities to understand how policies support or hinder urban agriculture. But we're looking specifically at policies that affect the nexus, the food, energy, water dimensions of urban agriculture, rather than solely policies that allocate land for urban farming or only deal with limited aspects of the nexus. And finally, we're engaging the participants in this research project in scaling, thinking about scenarios that would help to scale urban agriculture up in the different cities in which we've done the study. And we're particularly interested in the resource needs for those cities to help scale urban agriculture. So these are the sites. My partners are in the UK, Paris, and Nantes, the rural area of Germany, and in Poland. And as you can see, the types of urban agriculture sites at each of the research cities vary quite a lot, from allotment gardens in Germany and Poland to community gardens, which there's a terminology issue in the UK. A community garden is like a commonly farmed urban farm run by a nonprofit in the US. And allotment gardens in Europe are what we call community gardens in the US. They're usually farmed by individuals or families with individual plots. And so the variety of projects make this research interesting and complex. These are just a list of our co-investigators. And we have a number of different processes for the research over the past 2 years and into the next year. We spent quite a lot of time at the beginning of the project identifying the key indicators that we wanted to measure in the project. This is a chart showing just a select number of those indicators that reflect inputs to urban agriculture, everything from water and energy to material supplies, infrastructure, the land area, and of course the people who are involved in these projects. The outputs that we've been measuring include things like the obvious ones: how much is being produced, what types of crops are being grown, what kinds of wastes are being recycled through composting, the condition and types of soils and soil amendments that are being developed on the farms, and the social impacts. What are the human outputs of these projects? So we developed a relational database. This is a product that we decided to use called Airtable. Some of you may have heard of it. It's increasingly popular, but it's a cloud-based relational database so that we could have an efficient database of all of these inputs and outputs. And I'd like to, if this allows me to, show you the database in real time. Michael or Celia, is this showing my website?
I think it's still your PowerPoint slide.
Okay, so I have to switch the share. Sorry about that. Is the website now showing?
Yes.
Okay, great. So on the left, you can see the complexity of this database. We've measured the details about each farm or garden, including the infrastructure for each. We've sent researchers out into the field to identify, these are the farms in New York City, every single piece of infrastructure, including the storage shed on the property, because what we wanted to do was to measure all of the materials used on each of these farms in each of these countries. As you can imagine, it's a really complex measurement task. We looked at all of the supplies that were being used, all of the substrate amendments, equipment and tools, the energy requirement for each of the tools. If it was electric drill, for example, the wattage used by the drill, the actual composition of fertilizers and pest control chemicals. And the farmers and gardeners in each city kept detailed logs of all of their activities, including planting and harvesting and soil amendment, watering. We have basic crop data, including the estimated value of each crop grown based on local pricing, commercial pricing, growing logs for each farm, inputs of data every time watering was done, fertilizing was done, harvesting was done, activities and events on each farm. As you know, urban agriculture is really about the social dimensions of the farms, and each farm has activities like class visits and educational opportunities, cooking demonstrations. Those were all recorded. And as I mentioned before, we surveyed the farmers and gardeners to understand their motivations and their self-assessed impacts of the farms. I want to show you what these look like. I'll just randomly pick some projects in the city of Nantes. Thanks to Google Images, we can see what these farms and gardens look like. And I should say that this project is meant to be an action research project in which the farmers and gardeners involved have been actively involved in looking at the data that they've been populating this database with. And it's an opportunity for the farmers and gardeners to understand how practices are actually implemented in different contexts, different cities and different countries. The Airtable tool enables us to create dashboards of information so that the projects can see, for example, this is a chart of food production by square meter, kilograms of food produced per square meter. So farmers and gardeners can see how their particular farm compares to others, both in their own city and also in other countries. I won't go into all the detail, but I'm happy to walk through other folks if you have specific questions about inputs and outputs or how we've expressed this data in the Q&A part of the session. And I'm also happy to share a view-only version of this website if people are interested in taking a look at the data. Let me go back to the PowerPoint presentation because I want to shift to talking about the analyses that we have underway. With our team at the University of Michigan, we're using life cycle assessment to try to understand the global warming potential of urban agriculture. And this is just one tiny slice of an analysis that's going on right now. But we're looking at the global warming potential of all of the individual crops grown on the farms in the different locations. And through life cycle assessment, we're able to use national estimates of the resource composition of the materials and the processes and the food outputs of all of the urban agriculture projects. And so the global warming potential sort of sums up all of the resource inputs to the infrastructure on the farms, the operations, the energy used in travel to and from the farms and gardens, and the all of those material inputs can be allocated in different ways by crop. In this case, this is a graph of the kilograms of CO2 equivalent per kilogram of tomatoes produced, and it's summed up by the individual countries. This is just a comparison of that same data, looking at few meter gardens and farms that are focused on food production and few meter gardens and farms that are primarily focused on non-food objectives, social objectives, economic development and community development objectives like the Farms at Nature projects. And it's just a comparison to national averages for greenhouse agriculture, polytunnel or conventional field agriculture in different countries. This is a similar comparison looking at global warming potential compared to different production methods in different countries. And we can do this for different crops produced, cucumbers and greens, for example. We're also looking at specific inputs that are used in agriculture, specifically water, because in our initial life cycle assessment analyses, we've found that water is probably the most important contributor to global warming potential in urban agriculture. So we've looked specifically at direct water use. Again, this is dividing it into farms and gardens that are focused on food production versus those that are focused on multiple dimensions or multiple outputs compared to market and conventional agriculture in the UK and the EU as an average. And what we're thinking through right now is what are the best ways to allocate the global warming potential? Is it by calories produced? Because food, crop production is not as interesting because the farms are all producing different types of crops. And obviously a pumpkin is much heavier in weight than kale, and it's not a really interesting comparison if we want to know, for example, whether urban agriculture can produce sufficient calories for a city and what that might mean in terms of climate change impacts of urban agriculture. We can allocate the global warming potential by the nutrient qualities of the produce, and there's a nutrient-rich food index that's produced to try to estimate the positive nutrients and negative attributes of food, and come up with an index that relates them to each other, so we can understand whether urban agriculture is helping to efficiently produce nutrition for a city, or we could look at economic value, which is the way that many analyses examine the global warming potential of agriculture. We've done a social impact analysis, and I'll explain a little bit about how this was done. We surveyed farmers and gardeners, as I mentioned. We've tried to look at the social impacts of urban agriculture overall, because that's interesting to find out whether people's motivations are similar and whether the self-assessed impacts of urban agriculture for themselves are similar across the different projects. But we also wanted to understand whether social impacts vary by type of farm or garden, the roles of the farmers and gardeners in the urban agriculture projects, and whether the food is self-consumed or given away or sold. And so we divided the types of farms and gardens in our project into these different categories. And we used factor analysis to try to reduce the different variables that we measured in the surveys into a more manageable, smaller set of dimensions. And so through factor analysis of our results, we were able to collapse 14 variables that we measured into 4 dimensions: overall well-being, nutrition or diet, socialization as an important outcome of urban agriculture, and economic benefits. And so we did a multivariate analysis of these 4 dimensions to test how people's motivations and self-assessed impacts differ across the farm types. And then we developed a multi-level model to test the relationships between the characteristics of the farmers and their motivations and impacts and the farms, so that we could understand what combination maximizes overall well-being. These are just some descriptive statistics of the results. As you can imagine, people are motivated by improving the environment, having access to fresh vegetables, having a place to relax. Interestingly, saving money was a very small motivation for most of the participants. In terms of impacts, overall mood and physical well-being were impacts that were important, or important outcomes for most of the participants in our projects. But when we looked at the factor loadings, we, as I said, collapsed these different impacts into 4 categories. And what we found was that there was an overall consistency in motivations and self-assessed impacts, but a significant variance across garden and farm types, that allotment gardens and working farms produced a higher level of general well-being that was significantly different than the other types of farms, and that socialization was more important at farms with collective production. That might seem self-evident than individual gardens, and that economic factors were more important for working farms than allotment gardens or community farms. I think the value of this analysis is not necessarily the specific findings for this sample of gardens and farms, but as a potential methodology to use in assessing and trying to model the effects of urban agriculture at a larger scale. If we found that farms that had sort of owner or primary operators, mainly allotment gardens, showing higher well-being scores than other types of farms, or that the socialization motivation is a significant predictor of well-being, then we can begin to, as planners and policymakers, think about what are the different types of urban agriculture in a city that could potentially produce different types of social impacts. I'd have to say that because of our limited sample size, I think that this method of analysis could be expanded and would produce more reliable and interesting results at a larger scale. But I think the methodology that we developed was fairly unique and again, could help planners in cities understand how to potentially scale different types of urban agriculture in the city to produce different types of social benefits. We did a policy and scenario analysis in each of the different cities. The question we really wanted to ask is, and answer is, how existing Nexus policies either directly or indirectly affect urban agriculture. So each of the researchers assembled all of the policies that were addressing urban agriculture from one or more dimensions of the Nexus. We came up with 72 different policies across the 5 countries. Only about 10% actually addressed all 3 dimensions of the Nexus. Policies like green infrastructure policies that address maybe water, support food production as green infrastructure, and also consider the energy dimensions of the green infrastructure projects that are funded through a green infrastructure program. That's just one example. We did a content analysis of the policies to understand what factors in those policies promoted or hindered policies or programs that affected the nexus of urban agriculture. And so a policy might be to support or require green roofs on new buildings. There is one in New York City, but also in the EU, there are policies that promote green roofs, and whether those are extensive or intensive green roofs varies by location. But a policy like a green roof policy or a green infrastructure policy could potentially support or hinder urban agriculture. And the aim of this analysis is to understand how to develop policies in different cities and countries that can actually support an urban agriculture that benefits food, energy, water, and social dimensions of urban agriculture. So we're going through the process of interviewing and doing content analysis of the interview results of policy experts in each country to understand how, if urban agriculture were to be scaled in each of these different contexts, policies would need to support that scaling. And we're using a method called Q sorting to understand and evaluate each policy. So that the process involves engaging experts in assessing the type of policy and the ranking of how supportive each policy is of an urban agriculture nexus perspective. And the goal is to develop guidelines on how an ideal nexus-driven policy would look like and what impact it might have on urban agriculture. And finally, we really wanted to try to understand how the human dimension could be sort of incorporated into a food, energy, water, or nexus research process. And we just published a paper that talks about how social dimensions could be and ought to be incorporated into nexus research. It's not quite, it's not really intuitive or obvious how human dimensions of a process like urban agriculture can really be incorporated into an analysis that has conventionally looked at the quantitative dimensions of food, energy, food production, energy use, and water consumption. But our, our paper explains how we try to incorporate survey-based research on the human dimensions of these farms into our understanding of the quantitative impacts of urban agriculture. And I know I've covered a lot of material, and I want to end here and go into a Q&A discussion. I'm most interested in your thoughts about the research project, but I'm also happy to talk about specific questions you might have about each of the different research components. I think I stayed to my time, 30 minutes.
You absolutely did. Thank you, Nevin, for keeping to your time, and thank you for a very interesting, thoughtful presentation. Nuri, I think you'll handle questions that may have been posted in the chat. I guess, do you want to speak, Nuri, to people about how they can raise their hands for discussion?
Yes, thank you. I mean, actually, we don't have any questions yet on the chat, but if someone wants to open the discussion. Also to remind the rest of the attendees that I changed their names for guests, but that you can rename yourself in case you have a question.
And I'll start out.
Yeah, Jeffrey has raised the hand. Michael, sorry, I was just trying to go through.
Yeah.
I see Karen Landman is here. Hi, Karen. It's one of the wonderful things about the Zoom world is the ability of people from other countries to participate. Karen is an urban ag expert in Toronto.
All right, thank you. Welcome. So Jeffrey, we'll start from you.
Yeah, I have a question. Thank you so much. It's a fantastic presentation. Obviously, when you're talking about policymakers and decision makers, they're juggling so many balls in the air at the same time, and they're also juggling the balls of urban versus rural nexus, and the role of farming communities in and around the regions of the city. So my question gets to, if a city is trying to get to high efficiency energy use, for example, how do they look at the highest and best use of land in the city through that lens? In other words, could it be that compact cities where populations are using a lot of the available land, and some of the land is then set aside for community farms, but not really at the industrial scale? They're more kind of social, as you say, kind of social glue with the neighbor to neighbor, whereas the industrial scale of food is really sourced from either surrounding farms in the rural zones, which are actually under threat from suburban sprawl, and there's a sort of set aside opportunity there to protect farms. And then, and then the industrial scale kicks in, obviously, when you're looking at the volume of food that is required to feed a local population. So I guess it's a question of the highest and best use of land. Should some land be used for industrial scale farming within the city, or not? I'm just wondering how you grapple with those questions.
Sure. I mean, this is an age-old question in this area, and our analysis didn't and isn't going to calculate the trade-off between, for example, developing a transoriented development vacant site into a farm versus an office building, for example, or housing. Those are interesting questions for planners to try to figure out. But this is a complex sort of question to try to calculate. That there are designs for dense buildings that incorporate urban agriculture as part of the design. So there are opportunities to do both food production and housing in dense urban areas. There are policies. I mean, we recognize that open space is an important amenity and produces, health benefits and other benefits to communities. So we don't want our communities to be completely developed. So the question is, what is the appropriate balance? And I know Kubi Ackerman was presenting a few weeks ago about, the potential to farm different types of spaces, rooftops, for example, which then isn't a competition for the same uses on a single site. I think that would be a really interesting sort of next stage of this research, to try to understand what the different trade-offs are in terms of reducing suburban sprawl and allowing the construction of affordable housing in the city, and reducing energy consumption by promoting transit-oriented development versus sprawl.
I mean, and although rooftops are contested because you could put photovoltaic panels versus farm, for example.
That's right. And our analysis didn't look at those sorts of trade-offs either. But what we did, what we are estimating are the impacts of different types of urban farms. So a question could be that we hope to answer is, how can you improve the efficiency of urban agriculture if a decision is made that that a certain amount of urban agriculture is appropriate for a particular city? What are the resource needs that have to be considered? So if water is a big, well, two things. Infrastructure is a big contributor to global warming potential of the food produced from urban farms. And can we think about different types of infrastructure that could be funded, longer lasting, material efficient infrastructure that would make urban agriculture more efficient, and different types of water sources that wouldn't really require the kinds of energy inputs that potable water supplies require, groundwater, rainwater capture, etc.
Can I throw something in here? Oh, mute.
Yes, Charlie, please go on. Speaking of people joining from different countries,
Okay,
Charlie
so
is from the UK.
Can I speak? I don't know how to raise my hand except do that. My experience in London is that, like most cities in Europe and in North America, they get hot in the summer, especially. And so you have a heat island effect, which is a very big contributor to climate change, to global warming. It's not just carbon dioxide, it is temperature. Mm-hmm. And many cities get too hot. And the most fantastic way of cooling down is to cover rooftops, which you just hinted on, with vegetation, whether it's food or with agriculture or just vegetation, because you're doing two things. You're doing three things. You're cooling. If you look down on London from a helicopter, from Google Earth, what you see is rooftops, and most of them are black. So they're all radiating heat, and they're all heating up the city. If you cover them with vegetation, you have transpiration, you have cooling, and you restore the water cycle that was there before the city was built to a large extent. So in London, it's difficult to talk about a carbon footprint for water, because it's a very expensive thing to do, to collect water from a roof, take it to the drain, take it underground, purify it, and then recirculate it. If you can use it on the roof, which you can 90% of the time, that cuts out a whole chunk of cost in that use of water.
Mm-hmm. And most of the farms in our project are using potable water, which is incredibly inefficient. But there are investments in cities in rainwater capture infrastructure, rain barrels, and connections to adjacent roofs that aren't either extensively or intensively greened, that can water the gardens and farms.
Yeah, of course, rainwater is.
You raise, though, I think that could be answered from this, from an expanded version of this database, is what are the trade-offs between extensive and intensive, meaning sedum versus crops on a roof versus tree planting in the city. And one of the, I mean, I guess that from a planning perspective, the question is, what are the co-benefits of all of these different types of greening methods to reduce the urban heat island effect? And what's the proper balance for a city? You want parks with trees to produce shade, but then there's some value to food production, and of course, there are trade-offs in extensive versus intensive rooftops. I don't think we don't have the database right now to effectively make decisions about those trade-offs and understand what the precise energy and water impacts are.
Sure, I think it's worth pointing out that cities tend to be where they are because they were once the best places for agriculture. So if you take somewhere like London or Paris or New York or Alexandria or Cairo, they're where people used to farm. And because they farmed so successfully, and it was such a good region for farming, villages appeared, and villages became towns, and towns became cities, and the farmland got pushed out to the less suitable areas. So essentially, cities are ideal places for agriculture because that's how they started.
Yes, and as Carolyn Steele points out in her book, the street names in London were reflecting the role of agriculture in the city and around the city.
Yeah.
We have a question, one more question. Thank you, Charlie. We have one more question from Nicole Kenner. Nicole?
Yeah, hi, thank you for the talk. Just to introduce myself, I'm a PhD student at the University of Sheffield, but originally from Atlanta, and actually I'm doing some very similar research. I'm also modeling material flows on urban farms in the UK and in the US, in Atlanta, and then in some cities in the UK besides London. But I'm also looking at peri-urban and rural farms that sell into the same cities, so I'm trying to have those different scales of comparison. So I'm also doing life cycle assessments, but I was just wondering, for your study, are you doing life cycle assessments for each farm individually, or I didn't know if you were saying you were using average data. And I was also wondering if you're taking into account any kinds of like ecosystem service modeling within those life cycle assessments, which I don't think is a very common practice, but some people are doing. So yeah, that was my question.
So you should certainly speak with Silvio Caputo at Kent and maybe collaborate on some of the research that he's doing in the UK. But we are doing a life cycle analysis at each farm site as well. And as I mentioned, trying to understand in the aggregate how to allocate the global warming potential of the farms overall. So that data will be available probably in the next 3 months as this LCA research concludes.
And
I'm sorry, you had a second question.
Yeah, my second question was kind of just about if you're looking at ecosystem services and
yes,
things like carbon sequestration, modeling.
We have data on the variety of crops grown, but we didn't have the bandwidth to collect the data needed on pollinators in the different sites or any other kinds of important ecosystem services that are produced. So no, that could be a second phase of this research, but not yet.
And would you be taking into account, like, for example, woodland area on the farms, or if there's like any space set aside for not farming or anything like that?
In the database, we have the percentage of the area dedicated to non-food horticulture, pavement versus porous space, etc. As I mentioned, the database is really very, very detailed about the physical dimensions of all of these farms, and as well as the activities and throughputs.
Okay, great. And sorry, my final question, but I was just wondering if there are any really like innovative or interesting or exciting practices you saw on the farms that reduced their impacts, like anything you saw that was really novel that people were doing in their local areas in terms of recycling wastes or just any interesting practices?
Maybe I'm jaded because I've, doing this for so long that nothing seems particularly novel. We didn't find any sort of inventions that people had created, but I say that the differences in practices are important. For example, the New York City farms are all accessible by public transportation, and transportation impacts are important. So the mode of travel to and from the farms differed quite a lot, and obviously some cities in our case study were more amenable to bicycling to and from the farms. Rainwater capture was another sort of innovation in some of the farms that made a big difference because water was such an important impact.
Great, thank you so much.
Sure.
Thank you. We have another question from Robin.
Hi, Dr. Cohen. I've done a lot of educational work on, or like outreach on water footprints and the food, water, energy nexus. And what I realized in trying to, for example, come up with case studies is that there's not a lot of larger scale data to talk about with this kind of research. So I appreciate you putting actual data together that is at a comprehensible level. Can you talk about what would be required with scaling up to something like a watershed level if you're going to do a food, water, energy analysis at over a whole river system? What would it be involved with that?
This was extremely laborious, as you can imagine. So I think the resource needs would be maybe logarithmic larger. I didn't go into detail, but the method of data collection involved sort of professional research assistants collecting data on the infrastructure and materials, and the farmers and gardeners collecting all of the operational data. And that varied in reliability and data quality considerably. The farmers in Germany and Poland didn't use mobile phones and computers, and so they collected data on paper diaries that then had to be input. The Green City Forests in New York collects all of their data and inputs it every day into a Google spreadsheet, so that data was extremely reliable. I can't imagine the resource needs for a watershed or food shed scale analysis, but it would be substantial. One of the benefits of using a tool like Airtable is that, like Google Forms, it allows you to have a sort of easily accessible mobile device-based form that people can fill out that creates a record in the database. But you still would need enormous data cleaning and reliability checks built into the process. In some ways, this seems in retrospect like a fool's errand, or I don't know what the right expression is, but it's I believe that the value of this database is in its ability to be scaled. The question is whether the resources are there for researchers to actually build this out and apply it in other locations.
I mean, even in the best of times, we really lack data collection in this country. So it might fall to being done in another country. Well, I don't know. I can't envision any agency putting that kind of money into the research that would be involved in it. And I know through water footprint research that almost all the data that we've gotten on food is international.
I mean, the benefit of a database is that funders, whether they're government agencies or philanthropic funders, want some evidence that urban agriculture is valuable, and this is a comprehensive database that provides that kind of evidence. And also, evidence of the costs associated with urban agriculture. One of the reasons for writing Beyond the Kale, the book that Michael mentioned when he introduced me, is that you know, the naive assumption has always been that urban agriculture is necessarily beneficial, and there are, you know, important resources that are, you know, are competition between urban agriculture and other urban uses, and we need to understand what those are and what the trade-offs are.
Yep, I agree. And thank you for the research. It's really appreciated for those of us who try to bring it down to a, you know, an understandable public level.
Thanks. And there were some questions in the chat. I can't sort of wholesale share the database yet because we're still writing papers based on it and doing research based on it. But I'm happy on an individual basis if someone wants to get in touch with me to you know, to share a link, a read-only link that and walk you through the database if you're interested in either using it yourself or you know, maybe modifying it for your particular need.
Thank you. And we have one more person that wants to ask a question. Is it Leah? Are you?
Yeah, I'm here. I'm a student from the Technical University of Munich, and I'm studying political science. And I would be particularly interested if you have more further information about your policy research or about the policies that you have looked at.
So I probably should have done this talk 6 months from now or 8 months from now to be safe. The policy research is being done right now. So what we've done is collected and done content analysis of the 72 policies. They vary from, and I don't have the data in front of me to share with you on the screen, but they vary from national level agricultural policy. In the US, for example, the Farm Bill created an Office of Urban Agriculture to micro level policies around zoning for urban agriculture and, as I mentioned before, green infrastructure funding or priorities or requirements for green roofs. Those are the range of policies that we looked at. New York City had the most evolved and comprehensive set of policies that affect urban agriculture compared to the other 4 countries. But each country has sort of sets of policies. Paris has policies on encouraging urban agriculture, on both ground level urban agriculture and on flat roof buildings. But New York City, for a variety of historical and political reasons, seems to have been most advanced in terms of policies.
I have one more question. I think we still have time, or Cecilia?
We can do 1 or 2 more questions.
Is it Vivek?
Thanks for the great presentation. It is very inspirational, especially with the aspects which you unraveled with respect to personal well-being aspect of the urban farming. The other important question which I have is how much would it be feasible in tropical regions where, especially semi-arid regions where water stress is huge? How much is it like stressful for the water resources in the urban region, especially because the water harvesting methods which are mostly prescribed are getting it stored in the impervious water containers or barrels or underground water tanks. Then it will reduce the ecosystem services which will be possible when when water enters the soil layer, and it will make biodiversity to thrive. So I think there is trade-off when it comes to tropical region and semi-arid regions, isn't it?
That's very important. In many developing countries where urban agriculture is prominent, water recycling of wastewater is common, and that creates potential sanitary issues. I think so one question that we're trying to think through in this study is, what are we comparing urban agriculture to? Are we comparing it to conventional agriculture, to organic, conventional organic agriculture? And that is important because in an arid region, I think the analysis has to be whether urban agriculture can actually be more efficient for certain types of crops than conventional agriculture. And I think the data that we're collecting, the type of data we're collecting, could be used to answer that question. And the other important question is, what different types of urban agriculture practices are more water efficient than others? And our farms and gardens vary from people manually watering with cans to in-ground drip irrigation systems. And so the question then becomes, so what are if you're looking at the life cycle impacts, what are the impacts of building up infrastructure in the city to make a farm water efficient? And are those trade-offs worth it compared to other types of agriculture, conventional ground level agriculture, or maybe even controlled environment agriculture in the city, aquaponics, for example. So I didn't, again, answer your question, but I think raising that question is really critical. And my answer is that we have to begin to do the analyses that we're not doing yet to understand not just whether urban agriculture is appropriate for a city, but the scale and type of urban agriculture and the resources needed to make that agriculture efficient enough to be an improvement on the existing forms of food production in a location.
Yeah, thanks very much. Yeah.
I don't have any more questions in the chat. I don't know if anyone else wants to make a comment or something. Thank you.
Yes, thank you, Nuri. So I wanted to thank you, Nevin. I know we normally have a 1 o'clock time frame on this, or a 12:50 time frame. I'm not sure if the room can stay open for further discussion after the closing, but I think this has been really useful and great engagement from the audience. So I think that speaks to the value of your research and the interest that it has internationally. So thank you very much.
Well, thanks again for inviting me. I'm happy to stay if I can. If not, hopefully you know where to reach me. I'm at my computer all the time now until the pandemic is over. So I'm happy to chat about this some more.
Well, Nevin, thank you very much. I can stop the recording and leave the room open for a few more minutes if you wanted to chat with Nevin and get his contact info. I will stop the recording, and